Newsflash ninjas, if you don't ever want to miss this limit problem on your next exam, be sure to stick around until the end so you can learn how to crush this tricky limit problem. We've got the limit as x approaches infinity of x squared times sine of 1 over x, and I'm going to start by letting x grow towards infinity to see what this expression converges to. So we're going to get something that looks like infinity squared times the sine of 1 over infinity, and notice that for 1 over infinity, because the denominator is overtaking the numerator, we will see that this converges to 0. And so we have an expression now where on the right, you've got the sine of 0, which we know is 0, and infinity squared basically is infinity, right? So look at this, you've got infinity times 0, and this already looks like an indeterminate result, and we can't really tell what the answer is here, right? And this is where most students make a critical mistake. They'll be like, we've watched Dave's videos, we know this cool thing called L'Hopital's rule. When we're dealing with an indeterminate answer, we can just go ahead and apply it here. And there's a big problem. If you apply L'Hopital's rule with the original expression written as is, you will fail. And try it for yourself. Leave a comment below and tell me where you get stuck, because you will get stuck on it, unless you use this really cool trick that I'm about to show you. So hang on. What I'm going to do is for the original expression, notice how on the very top, I have x squared on the left-hand side, but we can use a reciprocal trick. Remember, x squared can be rewritten as 1 divided by 1 over x squared. And you're going to see why that's really useful here. So I'm going to use that reciprocal trick and rewrite the original problem like this. Now, what's cool about this is when we're talking about L'Hopital's rule, we're usually talking about a ratio of two functions. We're talking about f of x over g of x, and that's when we were talking about the indeterminate forms. And now we have something that looks just like that, where f of x is the top and g of x is this bottom, 1 over x squared. So what I'm going to do now is I'm going to let x approach infinity once again. And from the get-go, we can already see that for the top, we're going to have something similar as before, which it'll start looking like sine of 0, giving us a result of 0. And for the bottom, this 1 over infinity squared, that function g, 1 over x squared, is going to converge to 0 because, again, the denominator gets really large. So simplifying this further, we'll have sine of 0 over 0, giving us this indeterminate form, 0 over 0. Aha, this is allowed, and now we can actually use L'Hopital's rule. So what I'm going to do here is, for the numerator of this new expression, I'm going to call that f of x, which is that sine of 1 over x function, and for the denominator, I'm going to use 1 over x squared. And if you need a review on L'Hopital's rule, check out the video above. But moving on, what we got to do now is separately for both the top function f and then for the bottom function g, we take the derivative of each one by one. So for this function up here, sine of 1 over x, I'm going to use a chain rule by taking the derivative of the outer sine function first, giving me cosine of 1 over x. And then for the inner function, this 1 over x, for me, it always helps me mentally to think of this as a negative exponent, because then it's just a polynomial derivative, right? 1 over x is the same as x to the negative first, so that will give you negative x to the negative second. And then for the other function, g of x, is 1 over x squared, it's the same idea. Think of that as x to the negative second. And so its derivative is going to be negative 2 x to the negative third. Okay, so with L'Hopital's rule, if you remember, given an expression now that looks like f of x divided by g of x, we can basically say that because we have one of the allowed indeterminate forms, this is the same as the result of finding the limit as x approaches infinity of the derivative functions f prime of x divided by g prime of x. So plugging everything in, what I'm going to have on the top now for f's derivative will be cosine of 1 over x times this negative x to the negative second. And then for the denominator, the derivative of g is going to be negative 2 x to the negative third. So let's go ahead and simplify this first before evaluating it at infinity. You have a negative on top and bottom. Those will cancel out. And then because you've got x to the negative second over x to the negative third, in my head, I like to swap places. One that's on the denominator will now be on the numerator and vice versa because the powers are negative. So you'll basically have x cubed over x squared, giving you just x. And then the cosine of 1 over x remains the same. Okay. This is easy peasy, right? Because now if I let this converge to infinity for x, this becomes pretty straightforward. You get 1/2 times infinity times the cosine of 1 over infinity. And we know 1 over infinity converges to 0. So you're left with cosine of 0 here on the right, which we know is a value of 1. And boom, we actually have an answer here now.